Going back to our polarization encoded photonic qubit example, before measuring our photonic qubit in a superposition of the two linear polarizations, we can only know the probabilities of measuring the qubit with horizontal polarization and measuring the qubit with vertical polarization. When we measure the superposition, we can only end up with horizontal polarization or vertical polarization. We can no longer be in a superposition of the two polarizations. Even if we had two polarization encoded photonic qubits in the exact same superposition, we could get different polarizations when measuring each of them. In the graphic on this slide, we have optical components, a beam splitter, and photon detectors. This setup is often used to perform a very useful type of measurement on photonic qubits, known as a Bell state measurement, which we will see is very important later in this talk. Another nice property of photonic qubits, and particularly polarization encoded photonic qubits, is that we can actually see their quantum properties without use of expensive equipment. For example, through the use of polarized sunglasses. Let's say we have polarized sunglasses that only allow photons measured with vertical polarization to pass through them, and will block photons with horizontal polarization from passing through them. Most photons flying through the air will be in a superposition of horizontal and vertical polarization. When a photon reaches the sunglasses will measure the polarization of the photon and transmit it through or block it depending on the measurement result. These sunglasses will block about 50% of the light from going through them into your eyes. Through use of multiple polarization filters, we could increase or decrease the amount of light that will pass through the sunglasses depending on our sunglasses needs. A good example to see the effects of adding or subtracting filters is that of the three polarization filters experiment. I won't discuss that example today, but something that could be insightful to look up. It's another inexpensive, fun, and easy way to see quantum properties at home. Polarizing sunglasses are an example of how quantum properties can be used for practical purposes. Sunglasses can be a lifesaver on a bright day. But trust me, they're not nearly as exciting as the other entanglement-based quantum applications we will get to later in this talk.